to give you now is way more than what is in the book. But it is my experience that if you learn everything from the beginning, it makes more sense than if I just give you like the minimum amount. Okay? So, why am I telling you this? Because if you write this information down in your notebook, this will be good for this year and next year and when you get to calculus. Because it's the same always, okay? So, let me begin by saying,
Write this down.
aha, Mr. Apollonius's cone. Apollonius, by the way, was a very famous Greek mathematician from the ancient world. So, Apollonius noticed that if you take a cone and you slice it in many different ways, you get what are now known as the conic sections. And I think we discussed this once before.
Yeah.
And the conic section that we're going to see today is a parabola, which is when you slice the cone a little bit slanted wise, and you get this beautiful shape. Now this beautiful shape is extremely useful to us nowadays because a parabola has a very distinct thing, and it is that it's got this point, which they don't mention in the book just yet, but I'm going to mention it because it's really important, called a focus. And the focus is at a strategic place that is exactly equidistant everywhere. Okay? And the focus is when you see, have you ever seen a parabolic dish or a parabolic antenna? And they look like, sort of like this. And they've got this thing like here, like this.
Oh yeah.
Yeah? This thing is located at the focus. And why is it located at the focus? Because this thing is the receptor. And the receptor is the one that takes all the rays that are, or the waves that are being sent to it, so it receives them, and it makes it bounce towards the dish. And vice versa. Sometimes they miss this and they bounce off the dish to the receptor. Okay? Because it is particularly located at the focus, you can see the image or you can hear the sound. When this moves from the focus, it shifts somewhere, and that's why they have like these servo motors, and it sounds when it's trying to reach the focus. Because if it doesn't, it's not precisely at the focus, then you don't get a reception. It gets distorted because the waves won't be equally distributed. Okay? So, why is this called a parabolic dish? Because if you take a flat parabola and you hold it down here, which by the way down here is called a vertex, that lowermost point, if you make it spin, what you get as a result is a semi-bowl that looks like a parabola or a parabolic dish. Okay? Is that clear? Fine. So parabolas are like a big deal. Without parabolas, no satellites, because satellites all have the parabolic dishes. Without parabolas, forget about gaming. Video gaming with the world. Forget about Netflix. Forget about internet.
Sorry.
There would not be Wi-Fi
What?
without parabolic dishes. So parabolas are like the thing, okay?
The bomb.
The new best
The
friend.
bomb. Now,
The bomb.
as you know, and by the way, parabolas are part of a branch of math called, and it's got a cool name, which is why we're going to put it here. It is called analytic. This is just extra information. Geometry.
Makes me feel smart.
I know, that's what I'm telling you, what the name of it is. If you ever see a book where it says Algebra and Analytic Geometry and it sounds like all cool, it's this. It's conic sections and other things that you can use where you kind of like combine geometry with trigonometry kind of thing. Okay, so.
Seriously, what
Okay, so graphs with parabolas. I am going to start, you know that everything in math always has three components. It's got the concept that is always sort of weird and abstract. It's got the picture or the graphing side of it, and it's got the equation side of it, okay? I'm going to start with the equation side of it, and I'm going to go from there to the graph so that you understand both things simultaneously, okay? The formula in general for a parabola, the general form of the formula is like this. Don't get scared when you look at it.
Oh, that means I'm gonna get scared.
Okay? That's the general formula. Where A, B, C, and D are just numbers. Okay? Notice that the y doesn't have a y squared, like the x does. Okay? The general working formula for is like this. And this is the one that you're going to use to graph.
Oh yeah, because it has the slope and
Like I said, you won't see this formula till the very end of this book. To next year's book. But it's been my experience that it's easier if I explain everything from the beginning. So. Okay, that is the general formula, okay? What does each of those things mean?
Why we already know.
H comma K is going to be the vertex. I'll explain what that is. I sort of explained it already.
Yeah.
The y equal to H is going to be the axis of symmetry. I'm just going to that is as well.
What?
You don't know what you're asking for.
What?
Axis of
That's recorded.
Watching this in French. Okay, axis of symmetry. The focus, and this one is going to look really weird, but trust me, you won't have to use it just yet. But now you know what the focus is. The focus is and then there's something else called the what's it called?
You say I'm not understanding any of that.
What?
Symmetry.
Axis of symmetry, and it's my bad. It's X.
Maddie, where's your
You would.
pencil?
That's what I was saying.
Yeah.
We'll leave it there because I can't remember the other one. There's another one that looks like this.
No, it's not that.
And I can't remember the name of it. It's directrix. Ha. Okay.
Directus.
Directrix. It's a lot of letters, but I'm going to show you how to use it right now. Okay? So relax. Don't think it's as strange as it looks. It's not as bad as it looks.
Wait, direct what?
Directrix. Direct. There's a CP. Directrix. Wow. So let me begin by drawing.
Oh.
Oh, I'm sorry. You're filming.
Sounds like a You don't have to. You don't have to. You fix it. You don't have to hear it.
Okay. Like I said, a lot of those things you won't see till later, but I'd rather explain them because it's easier. when you have a parabola, a simple one, that says y equals x squared, and you put, for example, minus 3, minus 2, minus 1, minus 4, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. You know that you're just going to square it, right? And you're going to have 25, 16, 9, 4, 1, 0, 1, 4, 9, 16, 25. Right? Because you're just squaring the number. If you notice, when you have a, let me put, just so you see something, like this. If I do this, and I make something exactly like it, and I put the same exact numbers.
It's 5, 4,
It's opposite
2,
of
1. It's all positive.
Okay, they're all positive, just like these. But
5, 4, 3, 2, 1, 0, 1, 2.
what do you notice between the differences between the distances in between each of these? What do you notice? Over here, there's only a difference of 1, correct? Whereas here, as this number,
Five.
there's only a difference of 1 between 4 and 5. There's a difference of 9 between this one and this one. And this one, there's only a difference of 1 between 3 and 4, whereas in the result, there's a
7.
difference of 7.
Oh.
You see that?
Yeah.
9,
And
7.
over here, there's only a difference of 3.
Minus
and then
2,
5.
minus 2.
No,
9,
no, no,
7,
no, no.
5.
No, which is why I put, but look at 6. This one's going to be 36. There's a difference of 11.
Yeah,
And if I go up,
Look what I
6,
look what I
5.
noticed. 11, 9, 7, 5, 3, 1,
Primos.
0.
Odd.
But if you add like
it
2
seems
plus
like
3
it's
is
odd
5.
right now,
That's the distance between them.
but if I do, for example, 13 times 13, that's how much? 130.
169.
Huh?
It's always a
169.
difference of 2.
169. And 169 won't be 20 away from the other one. It's going to be larger because this is exponential, okay? So there won't, right now it looks like there's a pattern here and it's 3, 5, 7, 9, but that pattern ceases to exist the larger the number gets, okay? So, but you're right.
Yeah, because
You
like
saw a pattern there. And
between 2 and 3 it's
And
1.
the difference gets larger and larger and larger. Whereas here, the difference remains constant and it's always 1, right? So this is why this one is going to look like this, whereas this one is going to look like this. Do you see that difference? And it's going to get wider and wider and wider the higher you go, okay? Do you see that? Now, is that part clear?
Yeah.
Bye. If I graph this one, it's going to be here. Okay? It starts at 0, 0. Now, let's say that I take and I write y equals x squared plus 4. Where would that one be? Well, it's telling me to move 4 up in the y. So it would be up here. Right? And if I make it so that it is y equals to x squared minus 2, where do you think that would be? At minus 2. Okay? Does that make sense? Notice that this, yes.
So you always start in 0?
If you have it like this and just a basic, that's not the point. Don't try to generalize the always. Do you understand why this is plus 4, this is minus 2, and what it does to the graph? Do you understand that part? Like that's all you have to focus on. Yes.
If it's minus x squared, is it backwards?
Hold on. Exactly. And I was getting to it. Thank you, Kiko. If it's minus x squared, what do you think it does?
Down.
Smart guys. It would be like this.
Oh,
Right?
it's usual. No, it makes those weird shapes.
Bye. Is that clear?
We will do that in today's problem set or until the final.
Doesn't matter. Did you understand? Bye. So far, so good? Let me see how far this thing gets.
I hope not very far.
Yes, it does. Okay, so now, explain right now is like the basic, and it doesn't only apply to parabolas, it applies to everything. Anything regarding conic sections. So far so good? And you understand that, but notice one thing. This plus 4 and this
Is that
minus 2
y
is on the other side of the equal sign. It is not next to the y. Do you see that? If I were to place it next to the y, it would look like this. Do you agree?
Yes.
Then it would be an.
No. It's the same one. It's the same one. It's just that if I change sides of the equal sign, it's adding here,
Yeah.
it goes to the other side.
It's the
Y
same
plus 2 would equal x squared. Do you agree?
thing. Still the same thing, right?
It's still the same thing. What I'm trying to show you is, if I put it next to the y, it has a negative even though it moves up in the positive. That's what I'm trying to show you. Why am I trying to show you that? Because if I do the following, and I'm going to erase these, and it's going to take me a little long, and if we don't finish today, don't worry, I'll move everything.
Yeah, it's on.
Okay, so I don't know yet. Let's see if I finish this.
Hopefully no.
The test is okay. So let's say that I write y equals x minus 2 squared.
It is the problem.
It is next to the x. Just like over here, it is next to the y.
Oh, y equals x squared minus 4.
Minus 4.
So it would move on the
Wait,
x-axis
No.
to the positive side.
It will be
Why-
x minus
would-
2 times x minus
It would be here.
Wait.
What?
Ah,
I don't get that.
What?
I'll do another one. Don't
Just-
relax.
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 Don't relax.
Y equals x minus 5 squared.
No, I think
Guess where I'm gonna
minus
put it?
5. And 5.
Here. But why if it's a minus? Why am I moving it in the
Because minus
positive?
5 squared is 25.
It's-
Never mind.
Y equals x plus 3 squared. Where am I going to put that? Ah, you got it.
No one.
Okay,
Why?
But why?
That's so
Because, wait, don't take the check. Why? Listen, just like when I had the equal sign, it says y. You remember y is anything in this direction. It tells me, I take whatever I have in the x and I add 4. Who's going to move? The y, right? Because I'm adding 4 to the y. So it went up on the y. If I were to leave the x by itself here, I would have to pass this 3 to the other side, wouldn't I? And if I pass it to the other side, who's moving? The x. And how much is it moving? Minus 3.
Yeah.
Which is why it's over here.
Okay.
Is that clear?
Yes,
Yeah?
but why is it squared? Wouldn't if
The
we
square
squared
part,
3?
the square, right now don't worry about the square part, okay?
That's
Why is
good.
it squared? Because it is. That's what makes it a parabola. If it weren't squared, it would be a line, wouldn't it? Okay?
Yeah.
Now, is it clear how the numbers next to the letter affect it? Next to the variable affect it? If it's next to it, you would have to leave it by itself to see how much it really moves and in what direction. But if it's next to it, it's the opposite. Does that make sense? Yes.
I still don't get why.
Yeah.
It will
Why,
be,
why?
I still don't get why it would be 3 if there's a squared and
The square, please ignore the square for now. Later on,
then it would be x squared.
Hmm?
Then it would be
And
x
how
squared.
is it gonna be right now?
don't stop thinking algebra right now. Okay? Right now, this is somebody did it for you a long time ago. And they came up with this as an equation, not so that you would understand the algebra part of it, but because this is how it behaves when you graph it. Okay? So when you graph it and you do all the numbers, you get this chart. And when you plot the points, you get this graph. Okay? Forget about the algebra, forget about y with the numbers in themselves.
So miss,
Okay?
we can't just put, instead of x plus 3 squared, can we just put y equals x squared minus 3?
No, because if you put the 3 outside of here,
Then the y.
then it's the y that's moving, not the x. right? It's shifting here. So, let me do, just to clear that up, what would happen if I have something like this? Y equals x plus 6 minus 4.
No square?
Oh, sorry, square.
Okay, you
It's
still
telling you to move
-6.
6 in the x
Yeah. And minus
and
four.
minus 4 in the
So
y.
go down.
Oh,
So it's going down. So it's going to be minus 4, 1, 2, 3, 4 here,
And then the x in the
and
x.
6 in this direction, here.
That's not 6.
Yeah, yes, it is.
Imagine it's just this.
Imagine it's 6.
Okay? So it's the same thing, but it moves and it starts here.
When it says minus 4, you actually go down.
Aha!
It's just
Because
like
it's on the other side of the equal sign. On the other side of the equal sign for the y. But if you want, I can put it like this. So that it's the same as the x.
Yeah. But I prefer you doing the minus 4 mix.
I have no.
But do you
Yeah,
see?
then I
Huh?
can take a picture.
I don't.
You don't know what?
I'm confused.
Can you pause it for a sec?